Now let's take what we did with factorials and build it into this idea called permutations. Permutations is when you're trying to figure out how many different ways things can happen where order does matter. Okay? So let's go back. We now have 5 people and we have 5 chairs. How many different ways can we place 5 people in 5 chairs? And it's a permutation because order does matter. Realize person 1 can't sit in this chair and any other chair. Once they're assigned to a chair, that's it. Just like people finishing a race. You can't finish first and then come back and finish third too. Once you finish, you finish. So how do I fit 5 people in 5 chairs? How many different choices do I have for chair 1? I have 5 people. 5 people to choose from. Once I sit that person, I have 4. Once I sit that person, 3, etc. 2 and 1. Multiply them together. The short version of this is 5 factorial. We showed that on your calculator. 5 times 4 times 3 times 2 times 1. Okay? If I use my calculator to do this, 5 factorial gives me 120 different possibilities. Okay? Now, I want you to watch what happens if I just change one piece of this problem. So that was 5 people, 5 chairs. Now I'm going to do 5 people again. The only difference is I'm only going to do 3 chairs. Still the same amount of people, but less chairs. So now this truly becomes almost a race. Multiple people are in the race, but only 3 people can place, first, second, third. I'm going to use the same thought process. For the first chair, how many different people do I have to choose from? I have 5. Once one of them has made the decision, I now have to decide the second chair. How many different people can finish second? There's only 4 people left. How many people can finish third or sit in the third chair? I only have 3 left. I can't do any more. There are no more chairs to sit people. So this is where I stop my work. Instead of doing 5 factorial the whole way down, I'm only going to use part of my factorial. 5 times 4 times 3. So I had 5 people. That's where the 5 comes from. I have 3 chairs. I only take the first 3 numbers in my factorial calculation, and I stop. Now there is a way to do this on the calculator. I'm going to skip that for now because this is simple enough. We can just take the calculator and multiply. 5 times 4 is 20, times 3 is 60. 5 people need to sit. There's only 60 possibilities of which different ways I can arrange them in those 3 chairs. So notice the difference of what happened. Let's try one more example. So here are 10 racers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down there is the finish line. I can only place the top 3. How many different ways can I have somebody get first place? Well, I have 10 of them. So there are 10 different choices for my first place winner. One of them wins. I'm ready to pick my second place finisher. How many people do I have left to choose from? Only 9. I pick a second place winner. How many people do I have left to choose from? Only 8. Where did I get these 3 numbers? And notice I have to stop. I picked my third place finisher. There were 10 total racers, so that's where I start. And again, this is a part of my 10 factorial, but not all of it. How much of my factorial do I write out? Only as much as I can place or sit or choose, depending on what they want. Take those 3 numbers, 10 times 9 times 8. 10 times 9 times 8, which would be 720, and that gives me how many different ways this race could finish. 720 different ways.